Hello, SIGGRAPH LA. Incredible to be with you. 30 years ago, NVIDIA set out to build a new kind of computer, one that could solve problems traditional computers simply couldn't. Our first application was computer graphics, geometry, programmable shading, simulation, physics, materials, lighting. We came to SIGGRAPH where so many foundational ideas became real. The Utah teapot, 3D geometry processing, Turner-Whitted and ray tracing, Pixar, and programmable shading. These ideas changed computer graphics and computing. In 2001, NVIDIA invented the world's first programmable GPU. 5 years later, we introduced CUDA, turning the GPU into a parallel processor for science and engineering. In 2012, CUDA GPUs made first contact with AI. GPUs, the processor invented for graphics, sparked modern AI. Then, in 2018, right here at SIGGRAPH, we introduced RTX. AI comes back to graphics. Real-time ray tracing, neural rendering, DLSS, hand-coded algorithms fused with neural networks. With DLSS 1 out of every 4 pixels was inferred. Today, entire patches of the screen are inferred. Now at SIGGRAPH, we are expanding the canvas of creativity and expression. Artists and designers, as far back as Leonardo da Vinci, have invented technology in service of creativity. Creators and designers need tools powerful enough to expand their imagination, malleable enough to give them the freedom to shape ideas, and precise enough to realize their vision exactly as intended. We want the power of AI, but grounded in 3D, governed by physics, so that it is shapeable by creators. AI will generate amazing virtual worlds, and in these virtual worlds, the next era of AI, robotics, will begin. Before robots operate in the real world, they will learn in virtual worlds with synthetic experiences. That is why computer graphics matter more than ever. Whether for games, cinema, robotics, or factory digital twins, the goal is the same: to create virtual worlds that behave with the fidelity and realism of the physical world. There is a complete reset in computer graphics. No community is better able to shape its future than SIGGRAPH. You stand at the intersection of art, science, and engineering. You are the Da Vincis of our time. This is your moment.
Thank you. Hello, SIGGRAPH. Glad to be back. Physical AI has a data problem. Robots need to learn from the real world, but the real world only runs in real time. You cannot fast forward the reality. Let's look at different data sources for physical AI. We have tailored-up data, give you real demonstration. They are highly accurate, but painfully slow to collect. Classical simulation help you scale, but only the scenarios you can hand build. With internet, robots gain more knowledge, but the internet sees the world from human eyes, not robots. That's why World Foundation model changed the equation. If you have a model that can generate the world based on robots' perspective, data stops being something you collect. It becomes something you compute. Every GPU cycle turns compute into new scenarios, new variations, new test cases that no fleet can collect. That's why compute is data. That's why World Foundation model is the data engine of physical AI. With World Foundation models, robot capabilities scale with compute. Cosmos is NVIDIA's world foundation model. We built Cosmos to help physical AI developers build more generalizable physical AI systems. We built Cosmos to help developers in 3 ways: better data, better environments, and better starting points. Better data, physics-correct simulation generation and video analytics. Better environments, 1,000 kitchens, 1,000 warehouses, 1,000 weather conditions before your robot hit the real world. Better starting points, Cosmos are strong backbone to build passive models. You don't start from 0. Data, environments, starting points, all in one model. And let me show you the Cosmos video.
The real world is infinite and unpredictable. Physical AI needs data, but real-world data is impossible to scale. For physical AI, compute is data. This is NVIDIA Cosmos, the frontier of physical AI, an open, omni-model built on a new mixture of transformers architecture. Pixels, action, sound, and language flow into the auto-regressive transformer, which reasons, plans, and instructs the diffusion transformer, which generates what comes next. Developers post-train Cosmos across embodiments and use cases. As a VLM, Cosmos watches the physical world, understands what's happening, describing scenes, and flagging what matters. As a world model, Cosmos generates controllable, physics-aware synthetic video from text, images, video, and sound. When action conditioned, Cosmos is a simulator, inferring actions and generating the next plausible futures, closing the loop for policy training and evaluation. Post-train Cosmos, and it becomes a world action model, perceiving, reasoning, planning, generating actions for any embodiment, in any environment, for everything that moves. A new kind of data, a new kind of teacher, generated by compute. NVIDIA Cosmos, the open foundation model for developers of the age of physical AI.
What makes a foundation model is that its capability to consume enormous amounts of diverse data. When a model is trained with data from different tasks, something powerful happens. It learns the synergy. We train Cosmos with data from diverse physical AI tasks, including world understanding, prediction, simulation, and action. We use one backbone to solve all the different tasks. As neural network learn internal representation to solve the task, you might wonder why one representation can work for all the different tasks. And the answer is simple, because we live in one world governed by the same physics. The data for different physical AI tasks come from the same physics. That's why one shared representation works. And what even better, with this shared representation, one capability helps others stronger. So one world, one shared representation. And how do we learn the shared representation? We use mixture of transformer architecture. As shown in the slide, the architecture has 2 towers. On the left is the auto-regressive tower. It takes vision token, test token in, and predict test token one at a time. It does the causal attention. The auto-regressive tower is where the model reasons. It sees through what is, it sees in language to explain what it sees. On the right-hand side is the diffusion tower. This is where the model generates. It generates vision tokens, audio tokens, and action tokens. Every token in the diffusion tower attend to all other tokens in the diffusion tower, as well as the tokens in auto-request tower. This gives global understanding so that the generation output is globally coherent. So you have beautiful simulation results, physically correct. Each tower has its own layer norm and NLP, but the two towers share something critical in common, which is the multimodal attention. It is through the multimodal attention we align language, vision, audio, and action. Two towers, one shared representation. Action is the first-class modality in Cosmos. But whose action? A car steer, an arm reach, a hand grasp. Every embodiment speaks a different language. Our solution, to build a common vocabulary. We build a common vocabulary using a set of geometric primitives. Equal pose, where the body is, where the head toward. Effector poses, where the hands are, the grippers are. Grasp and gripper, what the hands and gripper are doing. With this, every embodiment becomes a combination of these primitives. Self-driving car, equal pose alone. Single arm robot, one effector, one gripper. Humanoid robot, one equal pose, two effectors, two graspers. And even human egocentric video fall in the same scheme. One equal pose, two effectors, two hands. This turns every human egocentric video into valuable training data for robot learning. And these primitives are purely geometric. They are grounded by the visual structure of the world, connecting pixels to motion, space, and control. This is why one world model can work for all the robots. Different bodies, one action language. And from here, what the model learns transfer across the embodiment. Cosmos model action and world states jointly. Action flow in two directions. A Cosmos model out of box supports three important physical AI modelings: forward dynamics, immerse dynamics, and policy. Forward dynamics, the action in, what the future states out. If the agent takes an action, what would be the result? The model plays the consequences before they happen. Immerse dynamics, visual transition in and action out. Which action causes what I just see? And this model is important because it turns every video into action-labeled training data valuable for robot learning. Policy, visual state in. What should the action be and what would be the outcome? What should the robot do to complete the task and what would be the visual consequences? This is the key of physical AI. Forward dynamic effect, immerse dynamic cause, and policy. Three important physical AI modelings in one model. Cosmos models are shipped with frontier world knowledge. With Cosmos, you never start from zero. You start from Cosmos. You post-train Cosmos in two directions. The first one is accuracy. Post-train Cosmos with your own data from your own embodiments. Then the graph is the story. The more custom data you put in, the better the data model. And this is not just a theory. We actually post-train Cosmos on Joy data set and achieve state-of-the-art pick-and-place policy results. The other direction is speed. Inference costs matter. We post-train Cosmos Super with distribution matching to reduce the number of denoising steps to 4. This leads to 25 times speed up for text-to-image and image-to-video generation results. And they are still reached state-of-the-art according to artificial analysis. So you can make generation 25 faster with distribution matching. And one more important is that we are releasing all these post-training scripts, the one we use to build custom model, accelerated model, so you can build your own. Both accuracy improvement post-training and speed improvement post-training can be done with a DGX station. What I presented you comes with a family of open models of different sizes for different deployment use cases. Last month in GTC Taipei, we released Cosmos 3 Nano and Cosmos 3 Super. Nano is a 16 billion parameter model. It's a great starting point for AV physical AI teams. It can be easily post-trained for your downstream application. Super comes with frontier wall fidelity. When accuracy is the primary concern, you start with Super. And today, we are releasing the last member of this family, Cosmos 3 Edge. Cosmos 3 Edge is a 4 billion parameter model. We built it for a single purpose, run real-time on devices, so that robot policy and video analytics can happen in JSON Thor, in RTX, in DGX Spark. One model lives where robot lives. No round trip to data center. So Edge for the robot, Nano for building, and Super for frontier. And let me show you a demo we did with Cosmos 3 Edge policy. We connect a robot arm and the camera to JSON Thor, the gray box on the table. The box runs Cosmos 3 Edge policy. The video feed in, the policy model analyze the video and predict the action, and the action control the robot arm to achieve the task. It's fast. It's fast enough for real-time control. This is what physical AI on device looks like. Cosmos is not a one-time act. It's a platform that has been compounding. We introduced Cosmos to the world in January 2025, 18 months ago. And from the art, you can see we have been building component by component. We have Cosmos Predict for world generation. We have Cosmos Reason for world understanding. We have Cosmos Policy for action. And in Cosmos 3, we unify all these Cosmos models into a single omni-modal world model. It can do everything the previous version can do in one body. And this is where we are today. And we are not stopping here. We have started building Cosmos 3.5, which is gonna bring in multi-view and other capabilities. Cosmos is an open platform. In addition to the open models, we also have open datasets, open libraries, and the open framework. We provide support, script to help people customize Cosmos model, as well as build your own world models. Cosmos is the frontier of AI, physical AI. And not just research, across 8 different benchmarks spanning generation, reasoning, and policy, Cosmos model ranked #1. And one more announcement. Building on top of OmniDream research, we are announcing Cosmos Dreams. Cosmos Dreams are neural closed-loop simulators. The first one we built is for autonomous vehicle. As the diagram shows here, You have a policy model, AlphaMayo here, take an action. Cosmos Dreams react the action and generate what the sensors would see. Photorealistic, frame by frame, condition on the actions. And it's fast. It's at interactive speed. So your car basically drive in the imaginations of Cosmos Dreams. And let's just show you a live demo. Andy, are you ready?
I'm ready, Ming-Yu. Thank you so much. I am so excited to show the audience our demo here. So Cosmos Dreams here is simulating an entire world from a single frame. For this demo experience, we're using a relatively sunny day, suburban neighborhood that you see everywhere, with a few cars, some lanes, things like that. You'll also see a bird's eye view on the bottom right-hand side, and that helps with the simulation to be accurate. So after the first frame, everything is completely generated from what you expect from the world, and also the inputs from my PS4 controller right here. What is incredible is this demo here, and this generation, is being done on a single RTX Pro 6000 workstation GPU. When we first started creating this demo, however, we needed to use 64 GB300 GPUs to bring this real-time demo to life. Then we were able to drive this real-time simulation with 16 Vera Rubin GPUs. What an improvement. However, now, with the new Cosmos model that Ming-Yu was showing earlier, it is on a single RTX Pro 6000 workstation GPU that you can see right here on my table.
Fantastic. So now AV autonomous vehicle developers can do everything in simulation. They can use Cosmos Dreams to do policy verification. They can know their accuracy before deploy the model in the real fleet. They can also use Cosmos Dreams to train their models, generating scenarios difficult to crack in the real world. Is that correct?
Absolutely. This accelerates their development velocity and saves a bunch on their operational costs.
Awesome. Thank you, Andy, and the team. Remember our promises. We built Cosmos to help physical AI developers in 3 ways: better data, better environment, and better starting points. And it's already happening. At the media, Metropolis VSS, video summarization and search, leverage Cosmos for video analytics. NVIDIA Isaac leverage Cosmos for realism enhancement and variation creation for robot policy training. Cosmos Dream closed-loop simulator built on top of Cosmos. AlphaMayo, NVIDIA's flagship robot taxi driving policy built on top of Cosmos. Good. NVIDIA's flagship humanoid policy built on top of Cosmos. And this is the most important slide of my part. We are building Cosmos platform with Cosmos Coalition members. They are contributing research, data, and evaluation to help us advance Cosmos platform. And Cosmos have been adopted by physical AI builders as shown in the second row. And there are more. It has reached millions of developers, joining us to accelerate the physical AI revolution. We have an amazing program lined up this week at SIGGRAPH, covering topics like USD, simulation, and AI. Here's the QR code. Hope to see you there. Thank you.